my dear students, this is Mrs. Shayma Gharib and today's lesson about equivalent fractions. First, let's revise some rules before you watch the video. You have to sit in a quiet place. You should have your pen and a piece of paper to take notes and to solve questions. You should pause the video after each question, then you try to answer on your own. Then you play the video to check your answer and to understand the question in case you get a wrong answer. Are you ready now? Let's start. Let's remember together, how do we write shaded parts as a fraction? We have here shaded parts and we want to write it as a fraction. Do you remember the rule? We write the number of shaded parts on top and the total number of parts at the bottom. So the number of shaded parts here is 9 and the total parts is 11. So this fraction will be 9 over 11 or 9 out of 11 or 9 11ths or 9 from each 11. Look at the second shape. We're going to do exactly the same. The number of shaded parts is 3 and the total number of parts is 12. So our fraction will be 3 over 12 or 3 12ths or 3 from each 12. Remember all the ways we read a fraction? Now look at this pizza. It's split into 2 equal parts as you can see. If we want to represent one of these 2 parts as a fraction, it will be 1 over 2. Now, look at this pizza. It's divided into 4 equal parts. And if I want to write this part, the shaded part, as a fraction, it will be 2 parts out of 4 parts. So it will be written as 2 over 4. What about the next one? This pizza is divided into 8 equal parts. So if I want to write the shaded part as a fraction, it will be 4 shaded parts out of 8 parts, which is 4 over 8. What do you notice about all these shaded parts here? All of them are equal, exactly the same amount. All of them, the 3 of them, exactly equal half of the pizza. That's why we call them equivalent fractions. So equivalent fractions mean equal fractions. Fractions that have the same value, but the only difference is they use different numbers. So here it's half, this one also half, this one also half. But here we wrote it as 1 over 2, here we wrote it as 2 over 4, and here we wrote it as 4 over 8. So equivalent fractions are equal fractions with different numbers. Now let's go to the next example. The shaded part here is 2 over 3. Here it will be 4 over 6. Look at the third one. 1, 2, 3, 4, 5, 6, 7, 8. So 8 over 12. And 12 is the total number of parts. What do you notice about all the 3 shaded parts here? They all equal. They all exactly the same amount. But what do you notice about the numbers in each fraction? They have different numbers. So these fractions are equal to each other. They are equivalent fractions. So now do you get the meaning of equivalent fractions? Let's go to the next one. We can get the equivalent fractions by multiplying both top and bottom by the same number. If I have a fraction, for example, 2 over 5 or 2/5, and I want to find an equivalent fraction to this fraction, what should I do? I can use multiplication. Read again. We can get the equivalent fractions by multiplying both top and bottom, the numerator and the denominator, by the same number. So I can choose any number. For example, let's multiply by 2. Up and down. Don't forget. Okay? So after we multiply, 2 times 2 equals 4. 5 times 2 equals 10. So the equivalent fraction of the 2/5 will be 4/10. They both are equal to each other. They both are the same exactly, but they have different numbers. Okay? Now let's try another example. 3/4 or 3/4. This time we are going to multiply by 3. As we said, we can multiply by any number. Any number. You can multiply by 2, by 3, by 4, by 5, by 10, whatever you want to multiply with. And don't forget, we multiply up and down, top and bottom, numerator and denominator by the same number. Okay, so 3 times 3 equals 9, and 4 times 3 equals 12. So 9/12 is equal to 3/4. Both of them are equivalent fractions. Are there any other way to get equivalent fractions? Yes, of course. Let's see. We can get equivalent fractions by dividing both top and bottom by the same number. So the other way is by dividing. Also, we're going to divide up and down by the same number. So we said we can multiply, and now we can also divide. So let's start dividing these two numbers. We can divide both of them by 5, and only by 5. We don't have any other number that we can divide with. So let's start. 5 divided by 5 and 15 divided by 5. 5 divided by 5 equals 1, and 15 divided by 5 equals 3. Let's try one more example. We have 4/20. I can divide up and down by 2, or I can divide up and down by 4. So let's start dividing by 4 up and down. So 4 divided by 4 and 20 divided by 4. So 4 divided by 4 equals 1, and 20 divided by 4 equals 5. So 1/5 is equal to 4/20, and 1/3 is equal to 5/15. These two fractions are equal to each other. They are equivalent fractions. And these two fractions are equal to each other. They are equivalent fractions. So we can get equivalent fractions using two ways. We can multiply both top and bottom by the same number, or we can divide both top and bottom by the same number. Okay, so now do you know how we can get equivalent fractions? By two ways, by multiplying or by dividing. Okay, now let's go to the next. Write 4 equivalent fractions for the half. I will ask you a question. Can you divide up and down? No. Why? Because it is in the simplest form. You cannot find a number that is a factor of 1 and 2 at the same time. Okay, so we're gonna use multiplying. So we can multiply many times by different numbers each time. Let's start. We'll do it together. First, let's start multiplying by 2. Do I multiply up only, or I should multiply up and down, up and down? Can I use different numbers? No, it should be the same number, up and down. So when I multiply 1/2 by 2, it will give me 1 times 2 equals 2. 2 times 2 equals 4. So 2/4 is equivalent to 1/2. Can you stop the video and try to find the more equivalent fractions to the half? Each time you can use different number than the 2. You multiply this half by a different number than the 2. Okay? Let's see. Here, I'm going to multiply by 3, for example, up and down. Let's start. 1 times 3, 3. 2 times 3, 6. This time, I'm going to multiply by 5. 1 times 5, 5. 2 times 5 equals 10. Let's try one more number. I will multiply by 10. This time, 1 times 10 is 10. 2 times 10 is 20. So all these fractions are equivalent fractions for the half, and all of them are equal to each other. So all equivalent fractions of the half, the numerator is half of the denominator. Did you notice that? Look, 1 is half of the 2. 2 is half of the 4. 3 is half of the 6. 5 is half of the 10. 10 is half of 20. So you can identify equivalent fractions of the half by looking at the numerator. Is it half of the denominator or not? If the numerator is half the denominator, or the number up is half the number down, so this fraction will be equal to the half. Okay? Let's go to next. How many equivalent fractions are there for the half? I want you to think. Here we got 1, 2, 3, 4. We have 4 equivalent fractions. Can we get any more equivalent fractions to the half? How many exactly? Are they 10, more than 10, 50, more than 50, 100, thousands? What do you think? Actually, there are an endless number of equivalent fractions for the half, because each time we can multiply by a different number, and numbers have no end. So we can try an endless number of trials and an endless number of equivalent fractions for the half, and also for any fraction. So any fraction has an endless or an infinite number of equivalent fractions. Okay? Do you understand this? Let's go to the next. Look at this fraction. 2/5 equals to another fraction. 4 over a missing number. There is a missing number here. What should I do? How to get this missing number? This equal sign means these two fractions are equal to each other, okay? How to get the missing number here? Let's see. Start from the complete fraction towards the fraction that has missing number. This is the complete fraction, right? And this is the fraction that has a missing number. So I will start from this fraction towards the fraction with the missing. This 2 became 4. What happened? The 2 to be 4. What should I do? Multiply or divide? Don't say add, because we said we get equivalent fraction using only multiplying or dividing. Remember this. Only multiplying or dividing. The 2 became 4. What happened? Multiplied by 2. 2 times 2 equals 4. So I will do exactly the same with the 5. I will multiply the 5 by 2. So 5 by 2 equals, yes, 10. So the missing number here will be 10. So 2 over 5 equals 4 over 10. All right? Now, look at this example. I have a missing fraction here and a complete fraction here. So as we said, we're going to start from the complete fraction towards the fraction that has a missing number. So now I have 49 and I have 7. Here I have 28, but I have a missing number. So I will start from these two. 49 became 7. From the 49 to the 7. The 49 to be 7. What should I do? What happened to the 49 to be 7. Is it multiplication? No. Why? Because the number is getting smaller. 49 is a big number. It became 7, and same 7 is smaller, so it's a division. So 49 divided by what gives 7? 49 is a square number, which is 7 times 7. So if we divided the 49 by 7, it will give me 7. Then I will do exactly the same with the 28. 28 divided by 7 equals, how many 7s are there in 28? You can keep count by 7 and find out, or if you know the times table of 7, you will find that the missing number is 4. Okay, so 4 over 7 equal to 28 over 49. Both of them are equivalent fractions. Now let's go to the next example. 2 over 5, the missing number here is up, and what did we say? Start with the complete fraction towards the fraction that has a missing number. So the 5 became 15. What happened? Multiplied by 3. 5 times 3 equals 15. All right? So we're going to do exactly the same with the 2. 2 times 3 equals, what do you think? 6, of course. So 2/5 equals 6 over 15. Now look at this fraction. 16 over 28 equals what over 7? What did we say before? We are going to start from the given or the complete fraction towards the fraction that has a missing number. The 28 became 7. What happened? The number is getting smaller, which means I will use division. So 28 divided by what gives a 7? Divided by 4. I will do exactly the same with the 16. So 16 divided by 4 equals 4. So 16 over 28 is equal to 4 over 7. And both of them are equivalent fractions. Now it's questions time. Prepare your pen and paper and start to do the questions. Then you check your answer. Are you ready? Let's go. 2/5 equals 4 over a missing number. Do you remember what did we say? We started from the complete fraction towards the fraction with a missing number. The 2 became 4. What happened? Times 2. 2 times 2 equals 4. So I will do exactly the same with the 5. So it will be 10. So the answer will be 4 over 10. What about this fraction? Equals to 5 over a missing number. What do you think? Okay, from the complete fraction towards the fraction that has a missing digit. The 25 became 5. What happened? Division by 5. 25 divided by 5 equals 5. So 45 will be also divided by 5 equals 9. One more question. What over 5 equals 42 over 30? We said we start from the complete fraction towards the fraction that has a missing number. So the 30 became 5. What happened? It's getting smaller, so it's a division. 30 divided by what gives 5? 30 divided by 6. Now I'm going to do exactly the same with the 42 divided by 6 equals 7. One more example. 8 over what equals 56 over 77? I will start from the complete fraction towards the fraction that has a missing number. 56 became 8, so it's also division. So 56 divided by what equals 8? 56 divided by 7. So I will do exactly the same with the 77. 77 divided by 7 equals 11. Now let's do one more question. 32 over what gives 4 over 10? I will start from the given fraction towards the fraction that has a missing number. The 4 became 32. The 4 is getting bigger, so it is multiplication. 4 times 8 equals 32. So I will do exactly the same with the 10. 10 times 8 equals 80. So 32 over 80 equals 4 over 10. Now, what over 49 equals 4 over 7? Let's start from the complete fraction towards the fraction that has a missing number. The 7 became 49, so it's multiplied by 7. The 4, I will do the same exactly by multiplying by 7. So 4 times 7 equals, yes, 28. So 28 over 49 equals 4 over 7. Now look at this question. Which of these fractions are equivalent to 9 over 27? I have many fractions and I have to identify which of them is equal to the 9 over 7. In this case, what is the best way to find out the equivalent fractions? We have to put all fractions in the simplest form. Do you remember the simplest form? If you cannot remember the simplest form, please go to the video of simplest form and revise it before we start. As we said before, we find the simplest form by dividing up and down and only dividing up and down by the same number. So I will start by the given fraction here. I will divide 9 over 27 by the same number. Let's try dividing by 9. I can divide up and down by 9 to get the simplest form in one step. So the simplest form of my fraction will be 1 over 3. Now I want to identify which of these fractions is equal to 1 over 3. I will go to the first fraction here and I will try to put it in the simplest form. So now 18 over 36, its simplest form is 1 over 2. And this one, it's already in the simplest form, so it will be as it is, 1 over 3. 3 over 7, can I divide up and down by the same number? No, it's already in its simplest form, so it will stay as it is. 2 over 6, can I simplify it to the simplest form? Yes, I can divide up and down by 2. If you divide it up and down by 2, you will get 1 over 3. 4 over 12, I can divide up and down by 4. Or by 2, then you keep dividing until you get the simplest form. So its simplest form will be over 3. Now I have 3 equivalent fractions, which are 1 over 3 and 2 over 6 and 4 over 12. All of them are equivalent to the 9 over 27. Okay? Is this clear? So with this kind of questions, it's better to put all the fractions in the simplest form to identify the equivalent fractions. Now look at this example. Ali says 4 over 12 is equal to 3 over 9. Is Ali correct? Yes or no? And explain. Let's see. Of course, yes. Why? Let's try putting both of them in the simplest form and check together. 4 over 12, if we divide it up and down by 4, it will give me 1 over 3, right? If I divide it here up and down by 3, it will give me 3 divided by 3 equals 1 over 3. So both of them are equal. They both are equivalent fractions. So Ali is correct. Yes. Explain. So we're going to say what we did exactly here. They both have the same simplest form, and I have to mention this simplest form, which is 1 over 3. Both of them equals 1 over 3, which means both of them are equal. Okay? Now, let's sum up together, what did we learn today? First, equivalent fractions are fractions that have the same value but different digits. We can find equivalent fractions by multiplying both numerator and denominator by the same number. We can find equivalent fractions by dividing both numerator and denominator by the same number. So we can use multiplying or dividing. There are an infinite number of equivalent fractions for any fraction. In all the equivalent fractions of the half, the numerator is half the denominator. When you put all fractions in the simplest form, you can easily identify the equivalent fractions. When we have two equivalent fractions and one of them has a missing digit, it's easier to start from the complete fraction towards the fraction that has a missing number. This is the end of our lesson today. I hope you enjoyed the video, and if you have any question, please feel free to leave a comment and I will answer you as soon as possible. See you next video, and please remember that your feedback is highly appreciated. Thank you very much and see you soon.